So last episode, we saw how quantum mechanics broke classical physics. But today, we're going to explore an even more unsettling question. What exactly did it replace it with? So, welcome back to The Fundamental Why, and I'm your co-host, Sahil.
And I'm your other co-host, Carrie, and today we have an episode on part two of our quantum mechanics series. And today, we're not just diving into deep and complex, hard to understand equations within physics. Instead, we're asking whether possibilities themselves can be fundamentally real. And to help us in our discussion, we're thrilled to announce and invite our guest speaker
Mhm.
studying physics as an undergraduate at McGill University, Fanny Zhao.
So, thank you so much for being here.
Yeah, round of applause. Thank you.
Hello, thank you for having me.
And Fanny, before we start our discussion section, I'd like to give our viewers back at home a little bit more information about who you are, what you're studying, and what you do. So, Saho and I, we know that you have a deep interest in research, and recently you've been undertaking some very cool projects in experimental condensed matter physics, and you've been studying about graphene in your lab, specifically graphene synthesis, fabrication, and characterization. If you could talk a little bit about what you're doing in your lab and if there are any real-world applications as well.
Oh, yeah, absolutely. So, hello, my name is Fanny. I'm currently in my very last semester of my undergrad, and I work in experimental condensed matter physics. And like Carrie mentioned, that I study a material called graphene. It sounds complicated, but it's essentially a single layer carbon atom. What I study in particular is something called twisted bilayer graphene. This different arrangement between these two layers would create different properties. One in particular is something called superconductivity. I would say it's a quantum material to a
Yeah,
certain extent. So it's related to this podcast, I guess.
Wow, that
sure.
sounds
That
super
sounds that's kind of
interesting. Yeah,
interesting. Yeah,
thank
there's a
you
lot
for
of
your
things there. Yeah.
explanation. And also, we'd like to ask one final question about how you first got interested in physics or quantum mechanics.
Yeah, like I'm so glad you asked this question because when I was back in high school, I didn't consider physics as a path I would pursue. Um, Back in high school, I was very interested in math. It was something I was good at and something I was like, it's math. Like I can use it for anything. And I remember what got me into physics was actually through a podcast as well. I entered university, thought of doing a math focused math major alongside with physics. You know what? I like the math in terms of its applications, and I'm curious how I can apply the math. And in the meantime, I was taking physics as well. And I remember I was taking thermodynamics the same time I was taking partial differential equation. And I realized you can use heat equations, wave function, all these things applied to physics. And then that's when I realized I'm more into physics than math.
That was great to hear your background, your story there.
And now we'll just briefly move on
Sure.
to
So let's
our background,
a
brief background.
brief background section. Okay, so we've spoken about this idea, superposition. So what does it really mean? Well, you can think of it as in a superposition is a word used in quantum mechanics to describe a system that has or exists in multiple states simultaneously at once. So to understand what this term really means, I'll tell you what it doesn't mean first. Okay, so it doesn't mean, let's say, an electron is everywhere at once. Instead, it tells us that multiple possibilities exist at the same time, but those possibilities aren't definite or aren't realized yet. So these can be described as probabilities, but this superposition state is still undefined because we haven't made a measurement yet. And so a nice analogy here would be flipping a coin. Many people might think, is that superposition? Well, not really, because the moment the coin leaves your finger, the outcome is already decided. Because in principle, with all the variables like position, velocity, and the mass of the coin, you could calculate which face it's going to land, right? But imagine instead an undecided coin. That's the closest we can get there, okay? But our problem here now becomes, what exists before measurement? I've said that, okay, superposition kind of collapses into a definite outcome when you make a measurement, but what about before you make one? So, Kerry, I have a question for you. So do you think that a superposition is a statement about reality or just about ourselves?
Hmm. think that's a really good question. Is it like a fundamental property, or is it just due to some lack of knowledge
Yeah.
that we perhaps may have about our universe? And I think looking back at your coin analogy, flipping in the air, I think that perfectly demonstrates how it's more about reality itself. Because it's not directly, because if it was about us, then it would just be we haven't looked at the coin. That's
Yeah,
why
exactly.
we don't know what state it's in. But in reality, the coin itself hasn't decided. It's switching between both states at once. Only when we observe it does it actually choose one outcome and stick with it. That's why I think it's more about
Wow,
reality.
that's a good point. I think, right? Mathematically, it states it's about reality, but I guess intuitively, we always feel like how can something not be defined until we look at it, right? That just intuitively, it feels like we just lack knowledge. But as scientists have shown, it's more about the reality itself, right? That is that superposition kind of has to do with.
Yeah, so that perfectly transitions into how, like, is the world fuzzy or are we, in a sense? And that also nicely transitions into the next topic we want to talk about, the uncertainty principle. And this is directly correlated with superposition and something known as the Copenhagen interpretation. So the uncertainty principle, let's define it real quick. It's a principle that states that multiple, that some specific properties cannot simultaneously have precise values. So, for example, if we have position and momentum, the Heisenberg uncertainty principle states that you can't simultaneously have precise values for both of them at the same time. It's either precise for position and imprecise for momentum, or vice versa. So there's an easy analogy to understand. So if we look at a camera and its shutter speed, basically how many pictures it takes per second, if we have a very high shutter speed and I take a picture of a running man, for example, I'm going to get a very clear and precise picture. I'm going to be able to clearly see, pinpoint his exact position, but I won't be able to precisely know his momentum, the direction in which he's running. But if I have a lower shutter speed camera, the picture comes out more blurry. It's harder to see where he exactly is, but I can tell his direction, his momentum based on the blurred photos. But there's something that might come to mind when you think about this. Why can't we just develop a better technology
Yeah.
or more advanced methods to be able to see both of them at the same time? Isn't that a problem with us and not about reality itself in physics? Well, that brings us back to the thing we talked about in superposition. Is it more about us or reality? And once again, it's about reality. Even if we were to develop, we aren't able to develop actually a technology that can measure both of them at the same time, because it's a fundamental, based on mathematics and physics, it's fundamentally proven that you can't have both precise simultaneously.
No, so that was, I guess, a good analogy used to explain the uncertainty concept, how, it's fundamental to our world. But always is that element, of how can we really visualize something, a system not being defined, right? So that's why there's still a bit of debate around this idea, even though mathematics has shown it to be true. So I still have a question to you with uncertainty. So circling back to free will, that's always a nice concept, right, in quantum mechanics. So do you think here now we've introduced uncertainty? How does that connect to free will? Does it protect it or make it meaningless?
And that's a great question. If you guys remember from our previous episode as well, we also talked about how quantum mechanics might enable us free will with our guest speaker, Kanjin. And now that we introduced the uncertainty principle, I think it's more supporting of how it doesn't really lead to or cause free will. It just enables possibility for that to occur. Because the uncertainty principle is about how two values cannot both be precise at the same time. That doesn't directly lead to free will in a sense for us humans. It just enables there to be some subjectivity or probability within outcomes.
Yeah, that's a good idea because even though you have this new randomness, right, that's been introduced by quantum mechanics, random doesn't mean free, right? Because when something's random, you don't have control over it, right? Like a dice, when you roll it, you can't control what face it would end up in, right? Although even if it may not be predetermined according to determinism, so I guess that's why there's those two opposing stances, right, between
Yeah,
free will or
definitely.
not, or none, right? Yeah.
Mhm. And now that we've established both of these topics, let's move back and meet with our guest speaker, Fanny, in our discussion section.
I have a question for you. So, based on what we've covered on superposition, that's our topic there. Um, we've mainly covered talked about it in terms of like probabilities, right, and like possible outcomes before measurement, but we haven't really covered it in concrete and definite terms. So, my question to you is: do you think that superposition represents something physically real?
I think it's a very tricky question
Yeah.
to begin with. I want to say that superposition definitely represents something physical, but the definition of physically real would I would put a quotation mark on it. Um, I think you've definitely heard like people say like realism, like what is reality? I think that's something I honestly don't think I can fully explain. Like you mentioned, like superposition or taking a measurement, like what exactly is the definition of realism? Or like just kind of the jargon here, I guess. Um, I think I do believe in the concept that the there's pre-existing um, reality or pre-existing physical properties before the measurement. And I'm a firm believer in parallel universe.
Oh,
So so you see where I'm going with this. So I do think there is definitely some pre-existing things that were there. And then once we take the measurement, it's deterministic, right? That's basically a definition of quantum mechanics. Um, I don't know how I could define physically real because as a human being, I don't think we can simultaneously observe two outcomes like within our imagination. But I do think it's definitely, I do believe the existence of superposition, but was as an observer was the limit of scope. I'd say um, we can only observe one outcome, like I mentioned. Yeah, that's. I think that's the best answer I could have. It's a very deep question, and yeah.
Yeah, I think that's so great ideas you kind of raised there. We were able to make some observations that suggest superposition, even though you can't like observe the superposition itself, right? Like you can see the interference pattern. I think this goes back to the double slit experiment.
yeah.
Like,
And just like Saho said, like there's no way to actually see something existing in multiple
yeah,
states unless, like you said, we can go to like a parallel universe and see the other option happen. But yeah, it has like direct like implications that proves that it's real within the world around us. And now I have a brief question. So our universe right now, we know that quantum mechanics exists, it's been proven, and it directly goes against determinism in a way. So, would you believe that living in a deterministic universe would be more comforting than living in our universe today?
I would say no. It's well, as an experimentalist, I think we take advantage of the quantum behavior of materials, quantum behavior of systems. That's how we have developed all those fancy technologies nowadays, right? So, um, I would say I I would appreciate the uncertainty within our universe and the non-deterministic, the properties itself. I think it gives us a lot of freedom in terms of development, what we want to explore. And, if the world is just classical in every scope of view, I think there's so much limitations and there's no space for imagination.
yeah,
Um, so yeah, I would not say it's better when it's deterministic. I think the uncertainty definitely brings kind of like the how would I say it? I think the uncertainty make it difficult for us to understand and to have a certain predictability of behaviors, but it definitely gives more degrees of freedom and just more freedom for us to explore what we want to explore. So, yeah, no, I'd rather have what we have right now.
so I guess that makes sense. Like that, like the uncertainty can make life more interesting, right? At the same time, I think that there is like some, I guess, an opposing view that um, introducing this extra randomness doesn't guarantee free will, um, because when something's random, that means we lose control over it because like in the same way, like let's say you roll the dice, right? You can't control that outcome, right?
Yeah, like it kind of feels like you have no voice over your own life or
Yeah.
your own decisions if it would be fully deterministic.
So I guess I
Yes.
also that also leads me to my next question I want to ask you, Fanny. So, we know how physics and math, like at their core, they try to seek order and predictability. So, but our discussion has mainly been, I guess, about randomness, like superposition. So, do you think math and physics would be able to truly describe randomness, like given their fundamental nature of you know predictability?
Mm, I mean, at the moment, no.
Yeah.
uh, but I do think there. Um, I would hope that one day we could explain that randomness, that one day quantum mechanics is as intuitive as classical mechanics is to us, but it will be a long time from now. Well, at the moment, I think what we're trying to do with quantum mechanics, or not just quantum mechanics, with physics or math, trying to explain these phenomena is trying to approximate, right? Either through probability or through different kinds of modeling, we're trying to get as close as accurate it is to what we observe. So at the moment, obviously, it's just a, even if it's a really well developed model, it's just a very good approximation. It cannot fully explain it. But you know what? I have faith in physicists or mathematicians. I think one day in some many years later that it will be like a thorough model that can explain quantum mechanics in a very intuitive way.
Yeah, definitely. That makes sense because right now I think mathematics and physics, like it gives us like the formula, like the wave function. It's still up to randomness, but it's kind of funny how the math still gives structure to this randomness, right?
But I think there might be like fundamental limitation in which we rely on like formulas and like functions
Yeah.
to describe things in both math and physics. But like they're fundamentally based in which if you input a certain value, you're bound to get that another value 100% of the time. So it kind of seems limited in their ability to describe like random probabilities. And then lastly, moving on to our last question of our discussion section. So I'd like to ask you, what do you think is the role of physics in describing the world around us? Is the world objective or is it dependent on observers?
Ooh,
No.
it's deep. I think what we have right now in terms of physics, everything that we've developed is just trying to explain what we observe. We use different ideas and all these things. It's just trying to fundamentally from connect our observation to something that we can use equations, use functions, use modeling to explain. You're talking to an experimentalist, so I definitely have a certain bias there. I think mm, I would say physics. I think it's coming like what we do as physicists. I think it's essentially just using what we see and to use what we understand to make an approximation, kind of like to explain what we see. Um, I don't know if how I can answer this question the best way because,
Yeah.
like I said, I think it's just an explanation of the observation, and from our explanation, making hypotheses, and then maybe verifying our hypothesis, and maybe some kind of something surprises you, something that is unexpected happen, and then from that observation, we can make more predictions, explain more. So from an experimentalist approach, I think it's coming observation and then physical explanation, and then that like iterative process, kind of going back and forth. Yeah, but if you're interviewing a theorist, I think they would give you a slightly different answer there.
Yeah. I see.
Yeah, that's true. And I guess like the foundation of physics, like the scientific method, you have to like prove something's real through experiments, and that's through observation and our own like measurements. And But I think physicists, they're trying their best to explain the world as it is, but due to the limitations of like being human, we have to rely on
Yeah, also,
our senses and like machinery to measure things. We're currently just describing how the world is observed.
yeah,
The field of physics is always
yeah.
improving. We're getting better at being able to describe the world as it is. And that basically concludes the
That's
discussion
right.
section. And now we'd like to wrap it all up and give some final takeaways in our conclusion section.
Yeah, so I think one of the very important takeaways here, both with superposition and uncertainty, that we spoke about initially in our brief background section, was that reality isn't simply unknown to us, right? It's actually undecided itself. So getting around the idea to be able to into understand that takes some time, I guess, but um, only when you make that measurement, I guess, you can see a definite outcome. But before that, it's almost, I guess, in undefined state with multiple outcomes there. So yeah,
And then we'd like to thank our guest
yeah.
speaker,
Thank you so
Fanny,
much. Yeah,
for
so
coming on, giving her wonderful insight into our discussion section. We greatly value your time. I know our listeners at home are also
yeah, it's really great to
deeply
hear your
grateful.
insights, especially from an experimentalist. So
Yeah, like so involved in the research field to give
yeah.
those precise insights. And I have one last final question for you. If you would like to tell our audience one final takeaway about your field of study or even physics in general, what would that takeaway be?
Ooh. um, well, I would say that sometimes physics sounds more complicated than it needs to be. Something I really despise is that physicists try to throw jargons at people to intimidate other
Oh,
people from entering the field. So I would say if for anyone, no matter what stage of life you are, if you're interested in physics, just remember it's just the universe. It's just the world that we live in, and that's what we're trying to understand. Everyone is as confused as you are, no matter how much training you have. Even just talking to my supervisors, to like the some of the frontier physicists, like they're still learning. They're still learning about a lot of things. Um, so yeah, I think what physics taught me, and I kind of want to give away, is that be open-minded. There's always something to learn. Don't get scared. Everything, well, if you're interested, you'll understand eventually. Yeah, so just don't feel intimidated about physics. If you like it, enjoy it, learn it, and that's what all life research is about, I guess.
Yeah, thank you
sure.
for
So
that
yeah,
beautiful
thanks for that
takeaway.
insight.
Makes sense. If you're curious, then there shouldn't be any like boundaries to
Yeah,
limit you
yeah,
within like physics.
Absolutely.
And then we'd like thank you all for
yeah.
listening to our episode. We'd like to give
Yeah.
a brief teaser to our next episode as well, where we go over entanglement, where two particles can seemingly share the same reality even across the most vast of distances. And then we'll talk about how separation might actually be fundamental in our universe. So
Oh,
thank you all for listening. Thank you, Fanny, for
yeah,
coming
thanks a lot,
on.
man.
And make sure to like
Like
and
and subscribe.
subscribe, and we'll see
See you
you
all next
next
time.
time.